All right, welcome to this activity. Ooh, sorry, I'm just going to make that a little bigger. Uh, and I'm calling this Physics 1 kind of credit recovery assignment. And really, the goal of this activity is if you're feeling overwhelmed and you feel like you're too far behind to try and learn physics or do the activities to get a decent grade, then I really want you to try and focus on this one assignment. As I kind of put here, it's really a brief overview of what we've done so far this quarter. And so, if there's anything that you can focus on, it's trying to learn these basics and demonstrate that you've learned it. Okay, so there are some practice problems here for you, and then in doing this, I can improve your grade. So, if you have an F, depending how you do, if you go through this and you do well or ask for help and then get a good grade on it, then I can move you into a passing grade. If if you have a passing grade and maybe you're hoping to get a better passing grade, I can use this as an example of why you deserve a better grade. So this is an optional activity to really try and help some of you out. So. Uh, Complete this assignment, and doing well will demonstrate nearly proficient or proficient mastery of Physics 1 this first semester. Okay, and that's our goal. We really want to be getting a 2 or a 3 overall in the class. So, the first thing we learned this year is called linear motion. And to make it sound maybe less scary, we're learning about motion, okay, and patterns of motion. and and by working with motion, we're able to kind of solve some problems and figure out some numbers that kind of can be valuable information for us. So the first topic that we really started focusing on was velocity. In particular, a constant velocity. That means the velocity is not changing. And so a velocity is how fast an object is moving in a certain direction. So it's really common that people will refer to this as a speed. But speed technically is just how fast an object is moving. Velocity is how fast it's moving in a certain direction. So you can have a positive velocity, you can have a negative velocity. You can't really have a negative speed. Because you're going to be moving if you're at a negative speed. But you can have a negative velocity. So that's a little bit of the difference. So in our terms, we're going to refer to it as velocity, but in your head, feel free to think of it as speed. It's how fast something is going. Okay? So to calculate velocity, we need to know two things: the distance. And for most of these scenarios, I'm going to refer to a vehicle. Okay, so you can kind of picture a car. We need to know how far the car traveled, and we need to know how long or the time that it took to travel that distance. And then we can find this average velocity. So uh, we take distance divided by time, and that will give you your speed or your velocity. So you can use this equation to solve for velocity if you know the distance an object is traveling and how much time it took. By rewriting the equation, though, okay, we can kind of move them around. We can also find out how far something has traveled if we know its velocity or time, or how long something has been traveling, right, the time, if we know the distance and velocity. So, kind of looking here, okay, we've got calculating distance. And so, if I want to know, well, how far, uh, was it to grandma's house? Okay, and in this particular scenario, you knew the velocity. Your mom or dad or aunt or uncle or somebody was going 60 miles per hour on the freeway. So they're going 60 miles per hour. That's a velocity, and it took 3.5 hours. Okay, you could take that average velocity multiply it by 3.5 hours, and you'd get your distance. Uh, then calculating time. Okay, how long would it take? So the scenario would really be if you're trying to go 100 miles. Yeah, that's pretty far, right? 100 miles, and you're going 20 miles per hour. How long would it take you? Okay, and so you could answer that question using distance divided by velocity. Next, okay, some common units of measurement. So we have distance, and these are going to be really important, and they help you recognize what the scenario is saying. So a common unit of distance is going to be m, and that stands for meters. Or you'll see km, and that stands for kilometers. And we don't really usually here in the United States refer to meters or kilometers. We tend to do yards and miles, but in science and around the world, they tend to stay with meters and kilometers. But for reference, we also have miles here. Next, we have time. Hopefully, this sounds familiar, but S would stand for seconds. MIN or min is kind of short for minutes. And HR, is short for hours. And then you'll see with the velocity that it actually has 2 units. So again, our velocity equation was distance divided by time. And that's how the units are going to be written. So you have a distance, meters, divided by seconds, which is your time. And then the way we say that is this object is traveling at meters per second. It is going a certain amount of meters per second, or it's going a certain amount of kilometers per hour, or miles per hour. And technically, you can do any of the distances with any of the times, but these are the most common velocities that we're going to work with: meters per second, kilometers per hour, and miles per hour. Now, I want you to try and use these equations to solve these motion problems. So I've told you it's solving for distance, and therefore you need to find the calculating distance equation right here. Then in this scenario, you're going to get a velocity and you're going to get a time, and so you'll multiply them together. So you have here a velocity. I know it's a velocity because it's meters per second, right? That tells me it's a velocity for 20 seconds. So you can click this open and show your work. I highly recommend, this is a little text box, so you can click that you write out your equation. Velocity times time. Okay, so this will help you remember what numbers to plug in. And then it says, hint, don't forget the units. Okay, you're trying to answer a distance, which means it's going to be meters, kilometers, or miles. And in this scenario, it has given me meters. Okay, so for this first answer, you're going to get a number, and it's going to be an M for meters. Okay, you have another one to practice. And then you're going to practice solving for time. So solving for time, is right here. Distance divided by velocity. So all you have to do is try to choose the correct equation, and I try to tell you which one to use, and then enter those numbers. And I will give you a distance and I will give you a velocity to solve for time. Okay, so here we have a distance and then we have a velocity. So you can enter that into the equation. Use your calculator. You don't have to do this off the top of your head. And don't forget, solving for time, you're going to use a time unit. So in this case, it'll be seconds because that's the unit given to us. Another solving for time. And then a little more challenging solving for time, but really you get a velocity and a distance. Then solving for velocity, okay? This is kind of the big question here is distance divided by time, velocity. So you have it right here. When I scroll back down, I can use that. I've got a distance divided by time, seconds, 25 seconds. I enter that in the calculator and I can plug in my answer there. But please try and show your work so I can figure out if we're understanding it and if we're making mistakes, how to fix it. Okay, another practice problem for velocity. The next type of motion we talked about was quadratic motion, and this is a fancy way of saying acceleration, right? We've all sat in a car before, and you're stopped, and then you speed up, and you get to 45 miles per hour. You're speeding up to the speed limit, right? Well, acceleration then is the rate in which a velocity or speed changes. So we can actually make predictions based on the constant acceleration of an object. So here is our equation. Okay, we have A as acceleration, VF. So this is going to be your final velocity, or this is the velocity at the end of the scenario. And you're going to subtract the initial velocity, which is what is the speed or velocity that you started with, and then you go ahead and calculate that, and then you divide it by the time. So, and there's a reminder here for that as well. You can also rearrange this equation to help you solve for time. So if you're traveling a certain distance and you're accelerating at a certain rate, how long would it take you? You can figure that out with this equation here. And really, you just kind of flip the time and the acceleration. Some units of measurement for acceleration. We have meters per second, or kilometers per second, or miles per second. And really, this meters per second is going to be the most common one we use. And what that's saying is your velocity, your velocity is a meters per second, and it is changing every second. So that's why we see meters per second. Your velocity, your meters per second, is changing every second. And then so we have these equations. And again, you want to refer to the correct one. I tell you which one you're solving for. Solve for acceleration, which means I use this equation. And I just plug in the numbers. I've given you an initial velocity. I've given you a final velocity. And I give you a time. And that way you can plug that into your calculator with that equation. Okay, similar. I give you a starting and a final velocity, and then I give you a time, and then you can tell me the rate of acceleration. And these are some real numbers, by the way. Okay, for an airplane to take off, it has to go 78 meters per second. And if it takes much longer than 30 seconds, you're going to run out of runway. So this is pretty much the rate of acceleration for an airplane if you've ever been on one. And then solve for time with acceleration. So we have two different velocities. Okay, we have an initial velocity, and then we have a final velocity. And then you have the rate of acceleration and how long will it take to accelerate from 20 to 30 meters per second in this scenario. So you can again enter that into this equation and type it in your calculator. And if you show your work, again, I can really try and help figure out where the mistakes are. Okay, and those are the most important kind of concepts and abilities that we've learned this quarter so far. So if you can complete this, again, I will do everything I can to improve your overall grade. Let me know if you have questions.